Hello, Flat Earth researchers, debaters and debunkers. We are told that the spinning impossible Earth in the heliocentric model orbits a massive sun and has an axial tilt of 23.5 degrees at the moment, and this is somehow what gives us the seasons and different angles to view the sun at from different places in the world. I would like to raise a few of the issues I have with the globe, always have had, but was never really able to think of any alternative reasons until coming across the flat Earth. And it seems to make a lot more sense to me, and an increasing number of other people too, it seems. Here we've got just a 2D image of a massive sun with the impossible Earth and the moon there off to the right, and a shadow being cast by the Earth. You and I know this is not to scale, so don't give me any crap about that. Here we see the Earth in blue and half of it in shadow. We're told that the sun is massive and a long, long way away, making it appear smaller in the sky. Even so, that shouldn't make a difference to the light reaching the Earth. And so if it is lighting up half of the Earth, it should be doing so evenly. We shouldn't have weaker sunlight in the northern and southern hemispheres, because really with such a great distance and such a small curve, it really shouldn't make a difference, and we cannot say that sunlight is direct around the equator and indirect in the northern and southern hemispheres, because really, despite the distance, that sunlight should be reaching us in the same wide path. In fact, a geocentric ball Earth with a small sun, like the one illustrated here, would be much easier to swallow given the angles that we see the sun from different parts of the world, represented by those green lines there. If we were in the northern hemisphere, we would be looking south towards the sun, and if we were in the southern hemisphere, we'd be looking slightly north towards the sun, whereas in the equator it would be directly above our heads. But even that doesn't really work for all the other reasons we believe the Earth to be a level plane. But apart from that, one major thing that really locks us into this geometry of the ball Earth is the artificial time zones that have been imposed on us, which do not truly reflect what is happening with the sun. These time zones are purely for commercial purposes, to have everybody on the same clock, and it is based on the geometry of a 360-degree circle, and which with that you can divide it up into your different time zones, segments that represent a clock face, and this is how the sun, moon and stars are used too. Any predictions that have been made for hundreds of years based on this geometry are simply timekeeping. You can tell when and where a celestial object will appear in the sky, but that gives us no indication of its proximity to us, or its size, or its speed. The only way we would ever find those things out for sure would be to go to those different celestial objects and spin around on them. So we're going to have a look at timeanddate.com and see how the days in different places show different times for what should be midday, when the sun is either directly overhead or at its zenith, its highest point in the day. So let's first have a look at Phuket, Thailand in May. And we'll see when we go down here that there is no problem with the angles and the times of the sun rising and setting. This does reflect how we actually see it based on perspective. But you can see here that it's 12:24 at the meridian when the sun is at its highest point. So it's already out of whack with us not being quite on the equator. And now we'll have a look at Birmingham in the UK, in the so-called northern hemisphere, where the sun is at its zenith there at a very different time. You'll see that it's 1 o'clock in the afternoon before the sun gets to its highest point in the sky. And you'll also notice that the heading is south. So like the geocentric model we had a look at just now with a smaller sun, that would kind of make sense because we are looking southward towards the smaller sun. But really, this is all about perspective over the flat Earth. And you can see here from the way the sun rises and sets that it fits with the way perspective works. As things come closer to us, they appear higher in the sky, even if they are keeping the same altitude above the Earth. So I have come to believe that this axial tilt of 23.5 degrees is actually the angle of perspective, the way we see things going off into the distance. And as well as shrinking, we see that things follow certain diagonal paths from the ground up to the horizon and from the sky down to the horizon. So I'd like to examine some of these clips I took to try and demonstrate how perspective works and how it would be quite possible for the sun to disappear beyond the horizon on a flat Earth. So one of the first things we can see here when we are looking at ground level is that the ground tries its best to come up to the midway point, and whether that's a small bump in the road or a rise, that is all that is required in front of us at this low level to start cutting things off. You can see as the motorcyclist goes down the road, he's seeming to sink. This road is quite flat, but those small bumps make a huge difference. Of course, as those people get smaller and smaller as they go into the distance, then more and more of them disappears, and we can see that this is exactly what happens to the sun. So I've put the protractor here slightly off-center because I'm really focusing on where the vehicles are going down the road. As they go in a straight line, we can see that they actually come in from the right and head towards the center point. And when we draw a line at 23.5 degrees, we can see that the vehicles seem to follow that line very nicely. And so do the posts on the left-hand side as well. Now, as we raise the camera here, we know that we are not seeing beyond the curve, but we can see beyond the little bumps that we were blocked by just now. And of course, we can see a lot more traffic. And as we bring the camera down again, slightly different location further down the road, but we will see that the horizon just rises up to the midway point, and that will be dependent on whatever is in front of it. And this is why it's possible for the sun to get cut off by the ground or the sea at the horizon, because really we're not seeing very far ahead on the ground or the sea, but of course we're seeing a lot more of the sky. So as the sun travels away and sinks to the horizon due to perspective, it will get cut off by the shorter distance of ground that we can see. Anyway, here again we have examples of the vehicles going in a straight line, but following these lines of perspective at 23.5 degrees. And that's why the Earth is flat. Thank you very much.